Alright, so I decided to make a video on how I calculated the different linkages for to get the steering to work right. What we have is we have a steering pipe here that is of a specific length, and inside of that pipe is the steering rod, and this rod has a throw from when it's at its furthest right direction of 0 to the furthest left position of 8.5 inches. So that's how much throw we have in this rod. And what we're trying to do is get this motor to turn the same amount left as it does right. And the goal also is to have it be able to turn an overall sweep of 70 degrees. So through here, being able to do 70 degrees. So to start doing this, what I did was I started with a sketch and sorry, not there. I want to start with a sketch on this plane, and the first thing I need to do is figure out where this thing pivots, where it turns, and it turns on this shaft here. So I take that and then I'll project where that shaft is onto this sketch so I know where this thing is turning. So if I leave this sketch and then I go and I turn, you can see that circle is where this thing spins around. Okay, so I'm going to go back into that sketch again, and the next thing I'm going to do is I'm going to draw a circle around that. So this is going to represent the basically the radius, the turn radius that we're going to be using, and we need to figure out the diameter of this circle. The next known value that we have is the 8.5, and so what I can do is I can draw a line on this circle, something like that, and I'll make that a construction line, and I'm going to make the length of this line 8.5 inches. So 8.5 here. So you can see now it's chosen to kind of put it at this arc, but it's an 8.5 inch line. 8.5 again is the maximum throw this rod has going in and out. Since this rod is horizontal in this drawing, I'm going to make the line I just made constrained to be horizontal. So now it's horizontal there. Now I can still change the radius of this, but I don't know what the radius is supposed to be. So to help me figure that out, I'm going to use some of the other goals that I have. So I have a line here, and it goes to that edge of the circle and that edge of the circle. Now I had said that my target is wanting to be a 70 degree turn radius. Okay, so there's 70 degrees. Now I can move the 70 degrees around here, and so I've got all kinds of stuff springing all over the place. What I want to do is have this sit halfway, because remember I said I wanted to be able to turn the same amount one direction as the other. So I'm going to draw another line that's vertical here, and I'll make that a construction line, and then I'm going to take the measurement from here to here and say that 70 degrees, make that half. Okay, so now what I've got is I've got lines that are halfway bisecting the angle of the max sweep that I want. Okay, so I can still move this thing, and the size of this circle is still sort of flexible. And so, but what the other thing I want to be able to do is I have this 8.5 line. So if I take this point, that's the end of that 8.5-inch line, and I say I want it to also be at the same line there, now what it's done is it's locked in that radius. Okay, so now I know where I need to put the center of my connecting rod. That's the point where it needs to be. Okay, and then the other thing that I can do is that knowing that the motor is straight right now, it's going straight, if I make this rod out 4 1/4, which is half of the full 8.5 from limit to limit, then that means the distance from this hole to this point right here is the distance that this rod needs to have. Let me go back here and just do that a minute. So I can project geometry here, and then I can take this point here to this point here, and now I know the length of the rod from the center to center needs to be 10 inches, 0.22. Okay, so that's the length that this rod needs to be, because this thing right now is sitting at halfway point in the rod throw, and the motor is sitting at center, so that means theoretically when I turn all the way one direction, it will get to the 70-degree limit, and when I turn all the way the other way, it'll be 35-degree limit, and then turning the other way, it'll be the other 35-degree, giving us a 70-degree sweep overall. So I've kind of already prepared some of these things, so what I'm going to do is get out of this sketch here, and I'm going to place the connecting rod angle and that connecting rod. So this is the piece of material that I need to mount onto the motor. So I'm going to quickly just add this to there and constrain that, and then also line up the holes in this bracket to the hole that's already in the motor. And we have that, and now I'm going to take the connecting rod here and fasten it to the bottom here, and then lock the two things together so that there's like a fake bolt there, and then I'm going to swing this over and constrain that surface to this surface. Kind of made it go way off into the wilderness there, but I'm going to bring it back here and then putting this bolt into that hole. Let me just get this turned. Right, so now we have this connecting rod that connects these two. This thing is sitting at halfway, so the motor should be straight. And so now what I'm going to do is go back into this part here, and I have it currently locked at the 4 1/4. I'm going to not lock it, and then I'm going to set the maximum to be 8.5 and the minimum to be 0. So that is the distance of the distance. Come on, inventor. from this edge to this edge. So when this edge is touches this edge, it's at 0. When that's all the way out to here, it's at 8.5. Okay, so Inventor kind of lost its mind a little bit here, so I'm going to put it back there. Okay, so now we can see that we're all in position. If I push this rod one direction, it does what I expect. Oops, let me go the other way here. So from the top, you can see that that moves, and now that moves. So now if I measure this, what I can do is I can open up that sketch again, and first of all I'm going to get rid of this because it's angry that that thing isn't there anymore. I'm going to draw a line that's parallel to, say, the transom, so it's there, and now I'm going to project a geometry on this edge here and on this edge here, and then I'm going to measure what this is. Okay, so that's telling me that that's 54.87, and then if I place another one from here to here, that's telling me that that's 123 and change, or 125 and change. Okay, so that's the 55 degrees this direction. And so now if I now move this to this, and you can see that I have the 55 degrees in that direction. And what's more is that the center line of the motor is sitting at that 35 degree angle, and when I move it the other direction, the center line of the motor is sitting at the other 35 degree angle, which tells me that I've got a full 70 degree of sweep with this configuration. So that's how I've figured out how to get this geometry to work and calculate everything that's required. I hope that made sense, and have a good day.